Hi, I'm Carrie Ellis, author of 21st Century Superhuman, and this is our 21st Century Superhuman show. Today I've got the crew with me from Peru with Dave Stewart, and we're calling it the Chinese Invasion. We've got some people from China down there, and they've been building projects. John Carl from Western Canada, who is one of the tech advisors with the Keshe Foundation. Hi, JC.
Hi, Carrie. How are you doing?
Hey, hi from Peru. Pretty hot today, and we've got a few people who'd like to introduce to you. Absolutely delighted to introduce to you, Carrie. Okay. If you would like to do that.
Sure. Let's just hold on one second. Let's say hello to Carl. Hey, Carl. Who's also in Peru.
Hi, everybody. Hi, everybody.
And Boss, who's in Sweden. Would you like to say hello real quick?
Sure. Hello, everybody. Nice to be here.
Hey, Boss, we call you our scientific wizard. We'll like hearing a few of your comments as we go along here. So sure, Dave, and come on over here, Eddie, too. I have a friend here from Kenya with us today who's just learning about the Keshe technology. Eddie, and go ahead and introduce your crew there, Dave. Dave, go ahead and introduce your crew.
Okay, great. We've got, let's start with Eduardo, originally from Italy. Hello, Eduardo. And you came here when?
We came here 1 week ago.
So
we spent here 1 week.
Right, and you're with Lynn?
Yes, with my partner Lynn and our friend Wan Chang.
Wan Chang. So, and also, if you want to ask Wan Chang any questions at all of what he's been doing here, because they came at the same time, you just ask Lynn, because she can translate. She speaks Chinese just as much as she speaks English. So you can ask what Wan Chang's been doing here for this week. And in the background, we've got Liliana. She's here. She's been making the pens and the cannons.
Hello, Liliana.
So she's not actually here. She'll be down in a moment.
So Dave, it's great to have you here. It's been a little bit quiet down there, but we're getting kind of rolling again, and we're excited about what you have going on. As always, you are a hub for exciting things getting developed, and I always honor and appreciate your amazing skill at putting together projects and getting them moving ahead, and I think that's what you're such a master at. So thank you so much for being here with us today. And I think we're going to start out and just let you go ahead and start sharing what you've been doing there. Should we do the pictures a little bit later and go ahead and do what you're doing in the physical, and I'll put you on full screen and you can tell us. So basically we're talking about the Keshe technology, and this is you're developing projects that are Keshe plasma devices and tools. And so go ahead and just start sharing with us what you're doing there, because it's pretty exciting.
Right, well, the first thing I'm going to do is I'm going to rock John Carl's socks off, okay?
That's a pretty tough thing to do, Dave. That's gorgeous.
That is awesome, Dave. Tell us about it.
Okay, well, I've got to give credit where credit is due. Eduardo, you've been mucking about with my three-phase machine, haven't you?
Yes.
So Eduardo's instrumental in making the frame and nano-coating it the Japanese way. I can tilt it, and you'll see that that's perfectly nano-coated with the hot. How did you do the nano-coating?
Just with a hot touch, with the fire.
I don't know if you've seen the video with the Japanese guy doing a whole 40-foot plank or 20-foot plank, but that's the way we did this, and we nano-coated the three-phase. We've got the three phases: phase 1, phase 2, phase 3. You've got your output condenser, and then on the top you've got your input condenser, and then you've got another set so you've got 3 stacker units all in one, and this is going to be plugged in to the three-phase in Hector's shop. It's quite an impressive bit of kit, isn't it? John, Carl, have you got any comments at this stage?
And Dave, just tell us what, for people who are ignorant, you know, I had my mother was watching one of these Keshe videos the other day, and she wrote me and she said, Cary, I don't really know what you guys are talking about. So just for those who are newer to this world, please tell us what the three-phase stacker is for.
Okay, well, if you want a technical answer, please ask John Carl, because you're going to get a better answer than what I'm going to give you, because I'm
the layman's answer to start with, and then John Carl can fill in behind you.
220 volts, this stacker, 110, and then the rest on the three-phase is the third phase, is that stacker. So you've got three stackers. John Carl, can you do any better than that?
Well, it's a
JC, let's explain too that we're talking plasma energy. Go ahead. Let me let you jump in and take it from the bottom up if you can.
well. These devices, like the one Dave has in his hands, this is a bridge between the plasma and the electricity. This is what it does is it takes a little tiny bit of electricity into the unit. That electricity acts as a trigger to generate or to condition the plasma, so that when the plasma leaves the unit, it's in a state that the electrical devices can use. Now, I understand that's not.
Holding it up there, that'd be great. So we can,
His arms will fall off.
Quite heavy, actually.
Yes, it's probably about 15 pounds.
More than that, I think.
The three-phase is a little more difficult to explain. Typically, in a normal household, when you have a regular plug, I don't have one right handy here to hold up, but you usually have two pins and then a ground. Those two pins, one of those is a common, which is like earth. It's not electrified. The other one is electrified. It's got actual electricity on there, and you need the two to allow a circuit to power, to allow the flow of electricity to pass. In a three-phase unit, you've got four. You've got one common, and you've got three that are electrified. But because of the 60 hertz, the frequency that the electricity is at, if you look at it as a sine wave, the one phase, the peak will be here, next phase, the peak will be here, the third phase, the peak will be here. They don't actually line up together. So when we're using that with electric motors, specifically electric motors, get a lot more power with a limited amount of electricity with that. One of the issues we were having with the Maggrav units, the factory units and the single stacker units, they only deal with one phase of that electricity at a time. This device that Dave is showing right now will nano-coat a three-phase system all at once. It'll do all three phases at once. So you won't have any sort of an imbalance if you're putting your Maggrav system on an industrial type situation.
So this is basically a unit that would be handle more, powering more things than just a household, or would someone want to use this in a household? And how close is this moving towards the? I mean, I know the one unit that the one guy had, he'd put his hand in front of it and it would disappear because there was kind of a space field getting set up, plasma field.
Yeah, when Ali did that, that's Ali, I can't remember, I don't want to destroy his last name, so I'm not even going to try to pronounce it. When he did that, he was working on a field reactor for a spaceship. This is a different system than what David has here. It's really unlikely you're going to get a field reaction from the stacker, because the shape of the Maggrav field is completely different.
Okay. And so this would be a unit for the shop that Dave is running there, is that correct? Or?
Yeah, most industrial places, you're likely to have a three-phase power system. Most houses, I have to say most because I know not all houses, but most houses are not three-phase. They're usually either two or one phase. I mean, the house I'm in right here is, we have two-phase energy coming, but that's for the dryer and the stove. And everything else runs on either one of the, one or the other of those phases, the fridge and the lights and everything you plug in. But if you add those two phases together, you'll get 220 volts in, North America, where they have a 110 volt system. You have to add two phases together to get 220 volts. One side is 110, the other side is 110.
So Dave, go ahead, tell us a little more and tell us how you got that crew gathered down there.
Okay, well, what we thought was, I mean, Eduardo's come here. I mean, explain really why you came here. And you can ask any questions you want to ask Eduardo just for the moment, because I must tell you that he's no spring chicken. This guy's got all kinds of tech stuff going on in his house, and he's showing us all kinds of tips. This has been reciprocal. This has been, you put something on the table and I'll put something on the table as well. It's been a great collective. So Eduardo, tell us a little bit about the reason why you're here.
Yeah, I can
So
hear.
Eduardo, a couple of questions. A, were you involved in the Keshe technology and going to the knowledge seekers workshops before you came, and how did you hear about it?
Yes, I started in October when they start broadcasting the knowledge seeker workshop, and actually then in the beginning of November I started building my first unit, and actually I built 4 units, none of them working as I like. I mean, I have an input, I have an output, but there is no in the way I measure, I didn't have any drop of consumption, you know. And I had a very big obstacle in making GANS. Really, I didn't have any clue about that, and that's the main reason I came here. And now it really helped a lot this week with Dave. So now I think I can make my GANS. And also, I had some issue with Nano-Coating. I think most of the problem came because my workshop in winter it's really cold. You know, the temperature inside is really cold. So I had to make something. I also tried the fire Nano-Coating with the torch, but it was not so good as I like to be. And here we made a very good work. So I hope now in the next weeks I can make work all these machines that I have.
Yeah, because we've been meticulously going through anything that Eduardo said to us this week that we weren't so sure where an error might have taken place. I like to call them experiences taking place. But I can tell you that when we did the nano-coating, we got it bone dry in the sun for the next phase, and we're getting really, really good results here now. We're getting results like for the pen, I can't touch this. The nano-coating is coming out really superb, and I'm very, very happy with it. And the secret, I do find that the secret is getting it bone dry in between each of the layers that you do. You know, the first one you put the irrigation where you put everything underneath the water and the caustic soda, and then the next one you put above, and then you let the vapor rise, slam the lid on tight and let the vapor do the work, and we're getting first class results.
That's
now
great. Dave, so you're putting it out in the sun in between each one of those plastic bags, right?
A massive tip, that one. That is a really good thing to do.
And especially because we had Lily a few weeks ago and she was explaining to us how just putting her items in the sun with salt water coating it was literally nano coating it. So that would be, sounds like it would accelerate nano coating or amplify it.
Absolutely, yeah. And then we did the same thing because Eduardo gave his complaint to us that he's struggling with the GANS. So we went, okay, well, let's do a real good one. Now, we had a problem here this last week that we've solved ourselves as well, because we always had bucket loads of the red GANS. We always had bucket loads of the white GANS. No problem at all making those. And the blue, John, as you know, it's always let me down. The blue's never worked out properly, but we've really tried to accelerate it. Well, I can confirm to you, there she goes. We're in business. That's pretty cool, John.
That is fantastic.
So, we found a few things that your show needs to know, Cary Ellis, and it was very, very fascinating in finding out that the smaller elements, we had 8-inch brass strips with the air and the water, with the air and the 1.5 volts, and we had small strips, about 4 inches. And the small strips, nano-coated and bare copper, produced far more GANs than the larger strips. That's quite remarkable. That's a new one for us, but it solved our crisis. By doing the two together, we solved our crisis in one day. So
you made brass GANs and copper GANs, right?
well, I've got brass GANs, yes, but it's only a small. This is copper GAN, CUO. This is
And so you used small strips of nano-coated or plain copper.
Yeah. Can you go and get these strips? We're going to go and show you what we used. Because it's vitally important that when we're making the scans, and if we've got a resolution now, which we definitely have, it's important to know the size of the strips you used in 15 litres of salt water with at least 15% salt water content. In 1.5 day, we produced that. Well, it's compressed down a bit now, but there's 3 inches in there. And that's a lot of GANs, that's a lot of blue.
Nice. So JC, what's the prescribed amount of salt because I think I used a higher percentage. My first batch of GANs went really well, and I think I had used a little higher percentage of salt in it.
Well, Vivek and I were discussing this at length not so long ago, and we're discovering from watching what people are doing that the volume of salt you're using partly depends on where you are on the planet. If I use 15% here, I get nothing. Vivek has to use 15 to 20% in Singapore, or he gets nothing.
Wow.
I'm using about 8 to 10%, and the issue I was having.
Well, it's almost got to be compatible with what salinity would stay in the water in your temperature of climate, it sounds like.
That may be a good way to think about it.
Because in cooler water, you're probably going to have lower salinity, and in a hotter climate, you're going to have higher salinity.
That's entirely possible. We don't know what correlation it is, but the trouble I was having before with my GANS production, I diluted my water. Basically, I poured a third of it out and filled it back up with clean distilled water, and now I'm getting very nice results. This is my CO2 GANS.
Beautiful.
And if I hold it up there for a few minutes, you can watch. It's a dynamic system, and every once in a while, a little ball will go shooting up to the top, and then it'll settle back down again. It's a very, very strong GANS. The surface, the material in there, it's very fluffy. And this is well settled. This has been sitting for several days, so it's well settled. But the surface is still very fluffy. It's not thick like toothpaste. Well, I can show you with the lead GANs. Actually, no, I just stirred that up, so that won't work. Here's the copper, and if you notice, it's the top and surface of the copper is very solid, very flat. It's like wet toothpaste. But my CO2 GANs, the surface, I don't know if you can see it. I'll try to show, but you notice there a part just went shooting up to the top. The surface is very fluffy like a cloud, which is exactly what you're looking for.
I feel like we're looking into a amazing alchemy laboratory. It's really an interesting feeling. I feel like we're talking to Gandalf.
But yeah. Got the hair for it.
Yeah. What does your lead GANs look like? Do you have some right there?
Yeah, I'll try not to stir it up. It settles really fast. But there's my lead GANs.
Wow. And what are you using to make that? I've kind of missed
lead and nano copper.
So where do you get the lead? Like
fishing weights.
Oh.
They're in the kitchen right now. They're sitting in the sink because I didn't want to have the lead out here where I work. But I took a piece of nano-coated wire. Where's that rose spool of wire? There it is. I used this wire, which is harvested from computer cable,
Yep.
Cat5 internet or network cable. And I nano-coated it a length of that. And then I just put the weights on it in a row and hung that into my salt bath.
Now, are you nano coating with heat or caustic?
Actually, depends on what I'm doing. If I'm doing GANS productions, I use caustic. If I'm doing energy systems, I use both heat and caustic.
Cool.
And I do the heat first because when you do the heat, you're setting your directions on your coils. And then I'll take that and I'll put it in a baggie and do a cold caustic method. And that the nano coating just gets really thick, really fast. And it's very, very nice.
Nice.
Now, I can confirm what Dave was saying about the quantity because basically my GANS was created. This isn't the same coil that I'm using, and it's about half of the size of the one I'm using. But I did it with a coil like this.
Nice.
And I nano-coated the coil, and then that just hangs over the side of the container. And you have your wire coming up, which you twist together at the top. And
Nice.
keep in mind, all of the direction of your twists, if you're doing it in coils, they all have to go the same way. If you have one going one way and then you connect it and it connects the other way, you're creating a barrier.
Okay.
Everything needs to go in the same direction.
Cool.
And I don't think with GANS production, I don't think it matters so much what direction you go, just so long as it's consistent throughout.
Cool. Let's see what Dave's got over there with his there.
Okay, well, we've got the elements here now. Eduardo's got the big ones. This is a small one. This produced more GANs in a 15-litre bucket than these. And you'll see there's a remarkable difference in size. You know, I mean, can you hold up the other one? Now this, biggest is not best in this particular case. Look at the size of these things. This one produced more GANs in half a day than this did in a day. So,
Dave, explain to us what we're seeing there, because I don't quite get it. What's at the top and what's at the bottom there? Those the nano-coated copper strips?
well, don't forget, when you dunk them in the water, you can see the water line here, and therefore the nano-coating has maintained itself at the top, but it's lost it, it's oxidized down at the bottom. We've lost the nano-coating, so we need to strip these clean again and get them down to bare copper. Then we've got to nano-coat them again. And what we will do is, instead of going for the big ones, what we'll do is we'll definitely give those another go. And we will have enough GANs for 200 years, if I can live that long.
And how will you clean them down to bare copper again?
Oh, we've got a drill. Eduardo's done a nice little job in the workshop. Don't forget, we've got a carpenter's shop here. And he's done a wonderful job where he's fixed the drill down, drilled a hole, put the drill through, put the gizmo on the end, which is like a scrubby, but it's a wire scrubby. And then you just put your copper on that and it comes up gleaming, shining, and you just clean it with a scrubby or a Scotch-Brite, anything you like. As long as you get that brass, that copper back to brand new again, you can nano-coat it.
I want to come to Peru and work in your shop.
I strongly recommend, if you're going to clean your copper, don't clean it with metal. Clean it with a plastic abrasive.
Okay.
Clean it with metal. If you clean it with metal, you're going to be embedding little bits of that metal into your copper, and over time you will contaminate it.
Okay, thanks, that's a good tip. I do know that turmeric paste, which we've got a market down the road here and they've got loads of turmeric, if you wipe it with either lime or turmeric paste, you're going to be protecting that copper to last it even longer. So turmeric apparently is the resolve for copper, and that's something that I'm going to look into. I'm going to go and buy some turmeric, and I'm going to try and leave these overnight, because what was happening was we were cleaning them and then they would get contaminated again just by the humidity in the air. So next week you got nice clean copper, come back 2 hours later and it's stained again, you know. So it's quite important that we do find a neutralizer for, or a, what's the word I'm looking for, John? A maintenance, a copper maintenance agent, and we do believe turmeric is that maintenance agent, you know.
Yeah,
Okay.
it's essentially it's a surface slipper. It's the turmeric or the lime, the acidity in the lime or the turmeric is what's actually, it's removing a little bit of the surface layers, getting you down to the clean copper.
Okay. Well,
Just make sure you wash it off really good before you try to nano-coat it, because it'll mess up your nano-coating.
okay. Well, don't forget the first nano-coating anyway is an irrigation jobby, and that pretty much cleans everything off that copper. Even if I've got my grubby hands on it, you know, it'll clean that off the first one. But I mean, I'm absolutely delighted to show you this. This is real progress here in Peru. John, what do you think about that? That's a pretty mountainous amount of blue, isn't it?
Yeah, that's a horrendous amount of material. I mean, this little bottle here has enough copper oxide in it that'll last me for generations. What you have there will power the planet for 10 years.
So, and you're going to hear Lynn now translating for Wan Chang, some of the things that are going on here.
Yeah, so why don't you introduce us to these folks as well and what they...
Okay, let's
they
speak to Lynn, and then Lynn can introduce Wan Chang. So, welcome, Lynn, to the show, and welcome also to Peru. You've been here a week now, so tell us a little bit about yourself.
Yeah, Lynn, tell us, were you listening to the Knowledge Seekers workshops, and then what were you guys already doing, and how did you hear about Dave, and what made you choose to come to Peru?
Yeah, I live with partner with Eduardo, so I'm not a very technical person, but I did listen the Knowledge Seeker workshop since last November, and in China I joined this Keshe China group. I did some translation on the teaching, because every teaching they do like a translation to Chinese. So since last December I just joined. I just volunteer, say let me do some work when I'm free. So it was helping me to understand about this technology as a, let's say, I'm a normal person, non-technical person at all. But in the gut level, I believe the free energy theory, somehow it's been, when Eduardo showed the interest and showed me this technology, the first reaction made was like, wow, this is going to be changing whole humanity. This is not a small thing. It's really, really big. That's how I know. So we've been working together as a team partnership, since then. And what brought us here, Eduardo already explained in the technical, reason why having this unit work. On top of that, another reason for me, or also for us, we really want to, because I witnessed him working alone for a couple of years already on the free energy device. And we really want to join to a big family or community. That's another reason to brought us here. So when we have contact with Dave, and they've offered this 1 week opportunity and has been, guide us to from beginning through the end, had the working unit that really excited us, which we just decided, let's go.
Well,
like that, yeah.
I mean, it's fantastic that I can turn around to you now and show you what they've been doing. John Carl, look at this. There you go. All the Wan Chang. Yeah, thank you.
Introduce Wan Chang a little bit too.
Wan Chang. This is Wan Chang's unit. Hi, Wan Chang. Hi. There you go. And that basically is all his bobbins. He's made all of those. He's made the condensers. He's made everything on that unit. But I've just given him one of our bases that he can use. At least he can say, look, my unit works. And when I go back to China, I'll take it back in kit form. And it's working. So, and likewise, Eduardo's machine, now he's got 4 at home that don't work. Well, he's got 1 here that does work. So, this is really exciting day today to switch these 2 machines on. I'm absolutely delighted. Where's your machine? Eduardo? Yeah. And this is all Eduardo's work. And this one works. We've tried it. We even had sparks from it. We troubleshot it. And then we've got it working. Eduardo got it working today. Absolutely delighted, aren't you? Yeah. So we can now back work his other 4 units because of all the things that Eduardo's learned from building this machine, this power reactor. So I suspect he's going to have 4 working machines when he goes back home.
Beautiful, Dave, and all there. Dave, tell us a little story of how you guys sat up with Vivek and JC into all hours of the night and kind of backtrack through your systems to figure out how to get it to work right.
Well, interestingly enough, these mistakes that we make are experiences. They're nothing more than experiences. And what we had was the guy who came here last month, who took his machine back to Chile, started complaining that his electricity went up. Now, that's obviously not what we want. We want the reverse of that. We want the electricity to go down and your bills to be cheaper. And every month it gets better and better and so on and so forth. So we've got a reversal there. We've got a mistake. We've got to find out that mistake. So I stayed up until about 2 o'clock in the morning with John, and we were troubleshooting the situation that we got, because what happened next was the machine, the power reactor here in Tarapoto in the electrical shop with Carlos Flores, was charging more electricity. So he was actually getting a bigger bill. So we were, what's going on here? John Carl, do you want to chip in a little bit about how we sort of troubleshot this?
Well, we looked at the systems, and I was involved in making that one unit that he's speaking of, Carlos's unit in the electrical shop. So I know it was done right. I know it works because they had it running on the bench. And then Carlos took it and put it on his breaker box directly, thinking that the electricity has to go through this device and then into the shop, whereas in fact, the exact opposite happens. You need your. Can
you say that one more time for those of us like electronically retarded?
Well, he took his Maggrav unit and he put it directly on the breakers, the switches that shut all the power off on your house, and he wired that directly into that instead of having a plug on it and you had to plug it into the wall, which is the original plan. For the Maggrav units was to nano-coat the grid as quickly as possible. And if you want to nano-coat the grid, that's how you do it. You're not going to get a whole lot of benefit in your house if you hook it up that way. But the grid is going to get a massive benefit. What we discovered was when he put that device on his electrical panel, all of a sudden he wasn't getting the benefit in his shop anymore. If you want the benefit in your house, you need to have your Maggrav unit as far away from the grid as possible. So now you got to think about this carefully. We've had people who have, their house and a shop and a barn, and it's all basically on the same grid. So do I put it in the barn? Do I put it in the shop? Keep it in the area that you want the benefit from. Like if you want it in your house, keep it in your house. But if you've got, say, a 2-story house, your breaker box is in the basement, put it in upstairs far bedroom so that as much of the house is between the Maggrav unit and the meter as possible. That way, when the majority of the plasma energy, which is reflected back into your house, it's not what's on the load, it's what's going the other way back into your house. The majority of that plasma gets into your wiring, sees your devices, applies a little bit of extra, helps out with powering those devices. And that's where you get your reduction in your power bill. If you, certain meters, I don't know exactly which designs, but we've had one report of a smart meter in, I believe it was either Quebec or Ontario, where the meter actually figured out that he's putting energy back in and he started metering him for that energy. And he had, they billed him for the energy he's putting back into the grid. But we've only had one instance of that, one report of that. I don't know if it's happened too many more times. But if you have the device with most of your house between the Maggrav and the meter, then any plasma that gets into your system that's reflected in, because if it's roughly a 4 to 6 times ratio from the load that you put on the Maggrav unit, any of that energy that gets back into your house is going to be distributed to your devices, and it's going to assist in operating those devices. They'll use less electricity, and your power bill will drop.
So it seems like that was a really key discussion that you guys were able to have and kind of troubleshoot this whole concept so that the units, they would really get how to make those units work.
Well, we're still not absolutely certain that that is what's causing his problem. It seems that's the most likely cause, because it was working fine on the bench. It was working good. He was running loads. Everything was working perfectly. The unit wasn't warming up. It was operating the way we expected to operate. And then once he moved it, then he lost that benefit. Because if I remember right, Dave, while he had it on the bench, he had a 10% drop. Is that correct?
Yeah, what we had is some consistencies here. The guy in Chile, because they speak the same language, of course, was in cahoots with Carlos Flores. Now, what I suspected happened was that because Carlos plugged his direct into the main, I think that Hector down in Chile connected his to the main and and then started reporting that he was getting a higher bill. It's gone up. So that gave us a consistency of 2 machines plugged into the red. It's called red here, by the way. And both bills went up. So, you know, what we diagnosed is the fact that Carlos did it wrong by putting it into the main. We suspected Hector did the same thing in Chile, and we're getting a message to him now to put it at the back of the house so that you can start feeding through your Nano-Coating right through all the wires of the house. We suspect that what we found, we will improve it, because we did get a 10% drop in the first month, and we were using around about 750 watts of power, and we were using quite a lot of resistive loadings. You know, we were using little soldering irons, we were using heat guns, all these things are resistive load, which really does commission your power reactor. So I suspect now he's going to move it today or tomorrow because he doesn't want to pay 25% more electricity. So I think it'll go back to where it was, and then he's just going to leave it there for 3 months, and I think we'll see a drastic reduction in his bills now.
I'm wondering if this, oh, go ahead, JC. Were you going to say something? I muted you, so you need to unmute.
Percent reduction. Oh, there we go. The fact that while it was on the bench, we were seeing a 10% reduction, that told me, because when Dave brought that up, I went, oh, okay, now I know what's going on. We know his unit's working. It's providing the plasma. And while it was on the bench, there was some devices between it and the grid connection. So the plasma was being reflected back into a system. It was helping power those devices, 10% of those devices. So we know it's working. We know it's actually supplying the plasma energy. And when he moved it, he lost that benefit. The only reason, other than he could have damaged it when he moved it, which is probably unlikely, would be that he's no longer getting the benefit of that reflected energy. So I recommended that they take the device off of their meter, put it right at the back of the shop, get as much of the devices that are in the shop between the grid and the Maggrav system as possible, and he should almost immediately return to that 10%, if not a little bit more, and start seeing improvement from that point on.
I'm wondering if this would be a place Boss might jump in and just share his experience. Oh, go ahead, Dave. Boss, do you feel like unmuting yourself and just, are you there sharing your experience?
Yeah, sure. I totally agree with because my first project was to buy a unit from Keshe Foundation, you know, a power home unit, and I was testing it on a really controlled environment. And that project, I just ended that, and I ended up with 37% saving from the setup there. And I think if I will continue that, I will be on like 50%. But the one thing I found out was that I really improved my saving when I connected exactly like John says, you know. I had like 500 watts on the output of the unit, and then I had 1300 watts on the input side. And then that was when I really got a good saving, you know, with the result of 37%. So it's very important, that thing, you know. You have to know how to put on your load.
And JC, what does that mean?
Well, it's. I was going to bring up, when you're working with the Maggrav devices, it's very counterintuitive. People will see this box with two plugs on it, and they'll think, okay, I plug it into the wall. Whatever I plug into it is going to be plasma powered. It does work that way, except the device actually puts more energy back into where you plug it in than what you plug into it. I don't know if I even have the right words to make this really, really clear. It works opposite to what you would expect. Now, we need a little bit of a load on the device so the device knows what you want, but the majority of the energy that comes out of the device comes out of the input where you plug it into the wall. And if you can wrap your head around that, it's pretty easy to see that you want all of your high load devices on that side of the device, not on the output of the device.
That's amazing.
It's very interesting. It took me a while to wrap my head around it. I'm really open to this sort of thing, but it took me a week to actually get it clear that this is how this thing works.
And boss, your unit was a Maggrav unit that you bought.
Yeah, that's one of my projects. You know, I've been evaluating this board unit, and now I'm also building one of myself, you know, but it's still not finished.
Cool, that's awesome. Well, we love your scientific reporting that you give us. It's very helpful, I think, to everyone.
Yeah, I like to share, you know.
Yeah, something I'd like to ask Dave is your fellow there who's got his 4 devices at home. He said that he doesn't believe they were working in accordance with the way he was measuring it. Now, if you have meters on the input and the output, you're not going to see any change. You're not going to see a difference because the meters aren't drawing any power. If you have a meter on the output of the device and another meter at the meter, why not just use that meter? Then you're going to see it on your input grid side meter. But that's really the only way to test, is to put the device on your system, load it properly, and just wait until you start seeing a trend in your bill. And because there's been lots and lots of people who they get a device, they build a device, they put a meter on both sides, they look at it, yeah, the wattage is the same, this is bunk. That's not how you do it. You can't measure the plasma. We don't have the tools to measure the plasma.
Yes, I can. Yeah, I can surely confirm that, because I did both things. You know, I was fiddling with my meters and getting result from that, and then when I compared it to the result from the electric bill, that was totally different. So yeah. I just skipped all the meters. You know, it doesn't work.
Yeah, you can't put a meter on the device and measure the input and the output. It won't give you any meaningful information.
Exactly.
Because as the plasma goes into your house, as it goes into your system where you've got your clock radio and your stove and a coffee maker and whatever else plugged in, a little bit of that plasma is going to go to each one of those devices and assist its operation. And it's going to reduce, each one of those devices is going to reduce its electricity load a little tiny bit. The only way to measure that is at the source of your electricity, which is the meter on your house. I think we lost Cary.
Have we lost Cary?
Well, it says she's still on, still recording. Oh, she just muted her camera. Okay, there we go.
Yeah, sorry, I had somebody walk in the house. I was just checking. Well, that's awesome information. Dave, let's go back to what you guys have been doing there, because you had a really great overview you were sharing with me. Do you want to screen share these pictures yet, or do you want to tell us more about what you're doing?
Well, yeah, it's been a busy week, and you've heard Lynn say that she's not very practical and she's not a techie or, well, I've got news for you. She's been doing something she's been very busy. Right, what have you been doing this week then, Lynn?
For the healthy path, I did. I would just follow the instruction.
Well, she's made, with Darko, she's made a stack of paint pads.
So you have the unit that seals the plastic, right?
Yeah, Darko's got the guillotine, Darko's got this plastic sealer. So, and then she marks also on there what you got in it, so you now know when you're speaking to someone what you're applying to them. And we've got them all in different sizes. So you buy these off us for a couple of sols, and that's big enough to put on the hand, and so on and so forth. And then you've got the big ones. I mean, there's hundreds and hundreds of them here. You've got the big ones where we've put all three together. So you can literally fold that up nice and neat, and you can use that around your wrist.
Wow, is that all three GANSes in there?
Yeah, so that's going to pretty much charge you up, and it's going to get rid of any pain that you might have. And it will probably, and it has, we proved it, because we had the lady here who had a big swelling on her hand after she went to the monkey project, the Sorelius project, and she got bitten by a monkey really bad, and she had a big hole in her hand here. I sealed that up with colloidal silver. I put a baggie on her, and within 2 days, that swelling was gone. So, you know, these work. I've got proven on several occasions now where it's removed all the swelling. A lady came to us with a swollen ankle as she tripped up. She'd had it 2 weeks, and it was gone in 3 hours. So we've also...
Dave, you guys might find this interesting. One of the ladies I did a show with this week, Heather, I did a show with Heather and Whitney called The Goddesses of GANS. Heather had the idea to put a different color paper inside each type of GANS pad. So she has blue, like I think she might have used a candy light or some kind of cloth. She got a cleaning cloth at the grocery store, a paper cleaning cloth. So they would have the blue pad, the red pad, and the white pad. So
excellent idea.
You guys might have fun with that down there as well.
Yeah, I might just look into that actually. That's a pretty cool idea. And it'll prettify, it'll look like the French flag, won't it?
Yeah. There you go. Great,
So, and now something else that we've been toying with are these health cannons. Now, I don't know if you saw my bucket that's frozen with the red.
Why don't I screen share a minute and we'll show the pictures. How many coils do you have in there, and how many tips running through?
Right, these are the cannons, and as you know, we can't touch them with our bare skin because it'll only work for me. So I have to be careful here. And there's your tip. It's got 4 points. What we do is you see the center one, which is there. That
right now, you've got it out of the camera field.
Oh, sorry. And we've got a double twist going on with 2 loops at the back here for the other ones to bend into. Martin Odema, I've followed him in Holland with these, and these are starting to show spectacular results of the torus field. I mean, I'm talking about that big. That's how big the torus field is. Wow. And then don't forget, if you see a torus field, you're also creating a mini black hole. So it's what's coming out of that black hole. It's probably your illness, or anything that you've got, because the torus field gathers through the body and goes right through the body, and then next minute it recognizes your DNA and then ejects that through that black hole. So these things work.
Beautiful explanation, Dave. Beautiful.
Well, I've got 36 of these and I'm selling them now. So when people come here, they can buy them off us. And here's a finished one because I've put epoxy around it. Now I've tested this one, and you can see through the epoxy that you can see that that's well locked in. And the end is here. You can see again the twists. And we've got some small crystals. Cara Nova here this week, and she brought some little crystals. So I'm going to be experimenting with a tiny little crystal dropping in there first. And I'm going to see what that does with frozen water, and test what the crystals do to these pens. So if you can imagine it now, that you've got this baggie on you, and you put that, say you've damaged your hand, you put that on the back of your hand, and then if you put the pen on the front of your hand, you can touch yourself with this now. You basically, what you've created is two toroidal fields, and anything that you've got wrong with you can be removed. And one of the items I'm going to be doing with our pens is I'm going to, if I get this one back again, I'm going to be putting a piece of copper on this loop at the back here, and I'm going to send that outside the machine that you can connect up to a salt water, and you can remove tumors, and you've got a place in the salt water for the tumor to go to. So in other words...
Beautiful explanation. Beautiful. Dave, let me screen share a minute, and I'll show your pictures of the ice showing what those do. Should we do that?
Yeah, spectacular, isn't it, Cary?
Yeah, let's do that quick a second here. Let's see.
There's all my machines.
That's the picture.
Yeah, Carl sent these pictures, but here, let's see where the ice is. Let's look at the ice first, because that's what we're talking about. These were just the ones you...
There you go.
So go ahead and talk about them a little bit.
Well, that one's got a bit of a reflection on it. If you go back to the other one that you got previous to that, well, that's holding the bucket up. You can see the torus field there in red goes right to the bottom of the, that's about 4 inches of water in there. So you've got a big torus field going on here. Go back to another.
Was that dye homogeneous all through the water before you started that experiment?
Absolutely. Now, this is the thing. When I put the dye in the water, you stir that water up. You've got, can you get the bucket? Yeah, we've got it here. Basically, you start off with that.
We can't...
Oh, we're screen sharing. We can't see your screen right now.
Oh, you can't. Okay. Well, I'm going to show it you in a minute then. But basically, you start off with consistent color water, red water, as if it was blood, and then you freeze it. Now, what happens when it starts freezing?
And did you just use food coloring for that?
I used what they put in the ice creams here, and it's just a food coloring. And what happened was, and you can see that on that picture you've got up there, is there's a big white rim right round that bottom of that bucket, all the way around that bucket, and it sucked the color, the red, towards the middle to create the torus field. And
oh my gosh, I never figured that out. So you've got a whole 5-gallon bucket there, and it pulled all the color into that circle, but there's still a whole bunch of clear ice outside of it. But originally that was all colored ice, right? All colored water.
that's right. And if you go back to another picture without that, yes, now look at that one. That is dynamic. Now, that is us suspending the health cannon on top of the water, and that you can see a clear white rim, an orange one on the outer side of that, and then this collection of red. And you can also see an energy field, which is the emission, which is the opposite of the torus field in white in this one. And that is the stuff that gets rid of your diseases and your illnesses and your swellings and whatever you've got wrong with you. There it is, shown clearly in the ice. It's absolutely wonderful to see that. And the icing on the cake really is, pardon the pun, Cary, the icing on the cake is that torus field. You can see that clear torus field there.
That is awesome. That is really cool.
So every one of our pens have tested out positive on this. Now, Eduardo did something else, and this is very, very useful tip for you. What he said was, that was somebody else's, wasn't it? What he said was he put 2 buckets of the same material. So in other words, a glass, exactly the same as the glass that you use. You use 2 of them, you fill them full of water, but you suspend your cannon over one, not the 2 of them. So you just put your cannon over one, and that means if you haven't got a dye color, you then compare the 2 ice cakes when you get them, and you will see clearly that the one with the cannon has got a real serious torus field going on. I think, Eduardo, you said that you'd probably like to do it again, but with a bigger bucket next time.
No, I want to do it again with a petri dish.
A petri dish.
It's a laboratory special dish where you can put just a little bit of water, so the freezing is instantaneous. It's instantaneous.
Oh,
It doesn't take longer, because when the freezing takes longer, you're not sure what is happening.
Well, I think we are sure what's happening because of the bucket that we had is substantial size, isn't it? You know, so therefore that shows clearly the size of the torus field.
In my opinion, what happens there is that this amount of water, that it's about 1.5 liters, will not freeze at the same time. It takes maybe half an hour. And in this half an hour, since the dye changes the density of the water just a little bit, this can be not completely true what you see, you know. If you have a very small amount of water that freezes instantly, that's much more clear evidence.
Okay, well, it sounds like Eduardo's going to take this to a new level now if he gets his petri dishes. And if you understand what he meant there, Cary, what he would like to see is a more instant freezing, so that it's going to give you a truer reflection of what you actually see, as opposed to what I've got. He's explaining there that it's taken a bit of time for that to gather. So is it really what you see is what you get? That's a good question.
Yeah, well, that's interesting. We'll be sure to take pictures, have him be sure and take pictures, and we'll watch the experiment.
Okay. And sorry, Cary.
That's all right. I was going to ask JC if he had any comments with the other pictures he's seen. I know I've seen a lot of pictures of this done on the golden age of GANS and stuff, and it's very similar what I've seen in other people's pictures.
Yeah, well, with a number of the pictures, you can actually see the fields dissipating. You can see in bubbles in the water as it freezes, the bubbles are actually elongated, and they're not a round bubble anymore. And if you just freeze a bucket of water, if it's got bubbles of air in it, they just freeze as little balls. Whereas you can actually see a structure within this. If you look really closely on some of these, you can see a kind of an egg or an ovoid sort of a shape in the very, very center, with all of these rays of bubbles coming out of them. It's very, very interesting.
Yeah.
I had one in my freezer. I just went and had a look at it, and I don't know, either I'm using the wrong water or my freezer's too cold or something's going on, but my ice is cracked up really bad, and it's all sorts of different densities within the ice. So I need to make some adjustments, do a little research to see if I can figure out how to freeze a nice, clear, clean block of ice, and then I'll be able to get a test. But the test that I did, if you stop the screen share for a sec, let me put my camera on. This is kind of interesting. What I did, on the last one I did, I had the health pen hanging above the table of water, and I took one of the caps from one of my bottles, and I put a little bit of CO2 GANS in it and set it on top of the whole structure, thinking I'm going to add some energy into the pen and I'll have a more pronounced field. But when it froze, that's what I got. And that was a solid blue, just GANS water. But the GANS actually collected into the center, and I don't think it froze, because the last one I did, I actually did it in one of these little bottles, and the bottle broke. So once it started melting, I took the glass off, and I ran it underwater to see if I could clear the surface and look inside, but it melted really fast, like insanely fast. And the GANS definitely does something. So this is now melting, and it's going to fall off if I tip it too far. But all of the CO2 GANS collected into the center of that little blob of ice, which is very interesting, and that's something I need to investigate. Tried a couple of different ways with a really thick GANS, really thin GANS with just the water. I need to do a couple more experiments on that, but it's something to look at.
Nice. So, Dave, anything else? I can go back to the screen sharing, the rest of those pictures. Anything else you want to tell us about adventures in Peru?
Well, we've got rattled off to a T now, making the paste. You can see now this. We put it on a tray. You stick that out in the sun, and you come back, and you've got a nice gooey mess.
That is is that the 3 GANSs together?
Yeah. So you got the red, white, and blue, and that will go into. We'll put that into a jar, and that will be for the machine. So basically what we've got, if we go back to the 3-phase, and when we have a look at this 3-phase, you can see now that we've put in here,
Right.
we've got that GANS, that paste in each one of these. So you got 3, 1, 2, 3, 1, 2, 3. Wherever you see that yellow top, and then you got 3 at the end there. So they're full of GANS. So this is going to be chucking out some kind of plasma. You know, I can't wait to get this one plugged in. I mean, wow, what do I expect, John? I mean, I've got 3 condensers on each. I've got 3 on the top, and then I've got 3 on the output here, and it's consistent. So you got 3 here, you got 3 at the top, and then you got 3 here and 3 at the bottom. I expect this to plug straight in. I've not connected the front. You'll see all the wires are loose at the front. They're all hanging out. And the reason is very simple. I'm not confident enough to connect this one up. I want Carlos Flores, our resident electro engineer, and he's a skilled man. I want him to connect this up and put it in the grid. He'll probably do it in about 15 minutes flat, but at least I'll be getting professional advice from him, and I'll get a pretty good job of him as well. And then we'll plug this in to the 3-phase that Hector uses in his shop that he's using right now, and we'll get that working. The only question I've got, John Carl, is how much load can I put on? What indicators should I be taking for the next 3 weeks, 21 days, loading this up?
I would think for that device, if you had like a 3-phase AC air conditioning, or a 3-phase motor, you want a purely inductive load on that. Usually 3-phase, unless it's an electric stove, you're not going to be using 3-phase in a resistive manner. But an inductive load on that, say like a 2-horse motor, would probably be just fine for that unit.
Okay, so let's repeat that. So a 2-horse motor or something like that. After about day 2, plug a 2. horse motor in there. Is that what you're saying? Because he's got like 3 big machines in there. You know, like a carpenter shop's got a planer and it's got a saw. Well, he hasn't got those things, but he's a cloth. He made these T-shirts. So he's got all the sewing machines and stuff like that there. And at the end of the day, I want all that running off this 3-phase machine. But,
Well,
sorry.
if your loads are balanced, you can put in different loads on each one of the 3 phases, like lights. You know, if he's an electrician, he understands how to split the phases properly. So he could have a bank of lights on each one of those 3 phases as a load. That would work as well. The idea is just simply load each one of those 3 devices equally. Now, if you're using a 3-phase unit as a load, I would strongly recommend an inductive motor. You're still muted, Dave.
I'll have to translate that. Inductive load. Can you translate that?
Yeah, you can have 2 kinds of load. Resistive load like a light bulb.
Yeah.
Inductive load like a motor.
A motor.
Yeah.
Okay.
If you're using inductive loads, the loading parameters that we're talking about don't really apply because the plasma really likes inductive systems. It has a problem with resistive systems because it's got to squeeze that massive amount of energy down into a little teeny tiny filament. And when you're asking plasma to make heat, it makes heat really, really well. And usually you burn them up. But an inductive system, it works on the fields already. So you should be able to, I think, for that device, hook it up, put, say, 50 watts of LED lighting on each phase for, say, 3 or 4 days, just to ensure that the nano-coating is functioning, and then you can apply it to like a 2-horse or a 3-horse 3-phase motor. And that should be fine.
I got a question that could really clarify this. With the 3-phase system, wouldn't it be acting as 3 individual stackers where one stacker is on from one phase, another stacker's for like the middle phase, and then the third stacker's for the third phase?
Exactly.
So the 3 stackers themselves wouldn't be wired together at all in any shape, manner, or form.
No, they're 3 independent systems, but when you're using the output of those systems, you're combining it into a single. That's why you'd want a balanced load on this. Because if you had, say, 100 watts on one, 200 watts on another, and 500 watts on the third one, your output energy that you're putting into a 3-phase motor, one of those phases is going to be very, very strong plasma. One of them is going to be very weak plasma. I think it's better. It probably won't make a difference, really, in the long run, that the low-end phase is going to take a little longer to nano-coat, that's all. Because the volume of your load is going to determine the speed of your nano-coating up to a point. But I still think intuitively you're better off if you have a nice balanced load between the 3 systems.
Okay, I'm going to go and take this to Carlos Flores. I've got several other machines here now that I've just had a wind from David, who's coming. He's flying into Bogota, and he wants to come here after Bogota. I think it's about June the 1st, and he's going to buy the surplus and donated. You can see them now down here. All the bobbins that I've got, several, maybe 10 machines, 10 power reactors. I'm going to be starting to connect those up this week now. And even you, Carl, maybe you'll be coming back here and getting your Macabre working, because that's about as good to go now, isn't it, Carl?
Yeah, I've got to make the capacitors and hook it up, and then it would be, you know, once I finish the Merkaba for housing the stacker.
You're coming through a little quiet, Carl. I'm not sure we can barely hear you, but.
Well, the fact is, Carl, that Eduardo and Wan Chung today made 6 capacitors each, that's 12. And then I made and put 18 on here. So that's 30 capacitors we've done today. And don't forget, 2 of those machines are plugged in and operating. So we've got a pretty fail-safe system now. And we're quite happy with that, John, aren't we? The way that we're doing the drying and such, you know.
Yeah, the capacitors have been the sticking point for a while now, and they're very fussy. They seem like a very simple system, but if you get them just a little bit off, you get sparks, and then you got to rip them apart and rebuild them, because as soon as they spark, they're no good anymore. But that's really the only failing point. If you just simply have the coils like this, there's no actual connection between the coils, which are on the powered side of the circuit, and the common. The common just goes straight through the unit, and the coil just adds an extra length. You know, if it fails, it just adds an extra length of wire onto the powered circuit. When you add the capacitors, then you have a powered circuit with a wire that's on neutral very close to it. So if you have a problem with how it's connected, if they're a little too close together, if they're touching, if the paper is not quite dry, then that's when you have your arcing. So if your device arcs and you have sparks and smoke, pretty much guaranteed the problem is either it's wired incorrectly or your capacitors are improper. But Dave's got a really good system now with capacitors. I think he's blown enough up that he knows how important that is.
Oh boy, have I blown a few of those things. And, you know, of course, we've got a stack of these now, and that's a GANS coated, painted medical paper, and that's bone dry. Now, no more fireworks for me, because the 30 capacitors that we had today, you had a bit of fun, didn't you, connecting your machine up today? Tell us a little bit about what happened.
No, it was just the inner wire was touching the external wire, so I got some sparks. That was. Yeah.
But it was not. What didn't damage your unit though?
No, it didn't damage the unit because it was just one spark and I just unplugged. Okay. But I have a question. What is the point to use this kind of asymmetrical capacitor? Because, you know, normal capacitor, the 2 plates are the same size. And this is very, very asymmetrical because you have only one wire in the middle, and then you have the coil outside.
Yeah, the way the plasma capacitors work is completely different from a conventional electrical capacitor. It's acting kind of as a conditioning for the plasma energy, so that instead of being really spiky, it's a little bit more smoother. It's really hard to describe. They're not absolutely necessary. You don't have to have them, but they make your device more efficient.
Right.
And the right way to connect them is to in the input and in the output with the neutral in common, right?
Say that again?
The way we connected was to put into between the input, the 2 wires of the input and the 2 wires of the output, having the neutral in common. Is it correct?
That's typical, yes. There's a number of ways to do this. One thing we're learning while we're building these is with your connections. Now, I know this isn't the capacitors themselves, but with your connections, where the plasma comes from should be the coil. Where it goes should be that pin that runs down the center. Now, with the capacitors, I would think that would apply as well. So there are some systems where we may have that wired backwards. Again, it's something we need to test. That's something we need to look at and see if that actually does apply. But the systems where we're using this type of connection, where you have that and then your connecting wire slips down inside of that with a loop on the end of it, these are turning out to be really, really effective. and they're easy to produce. The new Maggrav systems from Italy are as far as the manufacturing goes are simple. You take a stacker and you plug it into the one below it. You take the next one and you plug it into the one above it. There's no more of this getting in there and fiddling and fixing the wires and then painting them with caustic to get the coating done. Just plug it together, and they're working really well now. The new systems are excellent. We've solved most of the problems.
I see. Okay, thank you.
So you guys, I kind of like to sort of like come to closure if we can, but Dave, I want to make sure we're covering everything. Can you look at those few pictures of your station on my screen sharing quick? And I know you're really sure to come in. I'm getting a lot of feedback because you're not muted, so I'm going to mute you a second. But if we can, I'd like to just, hear a few more things from you, Dave. Let me switch to that screen sharing and show the few pictures of your site, and let's put the word out to people. And after, we'll unmute you in a minute and let you share how people can get in touch with you, how they could decide if they wanted to come there and what that would take to work on building units with you. And because we'd like to put that word out, because this is really a great offer that you have to all of the people that are getting ready to do this around the planet.
Okay. Thanks, Cary. Yeah, absolutely. And, you come here to Peru. We've got slots available for the end of May. If people just want to pick up and come here, you can do that. You can come. Our deal is $500. You make your machine. You not only make your machine, you learn how to do it. You learn how to do it properly, because it's not me. It's this team that we've got here. We've been working on these for a couple of years now. And what we're doing is we're actually starting to produce goods. And if you are like Eduardo, who couldn't work out what he was doing wrong and where he was doing wrong, you come here and build that machine, you're going to find out where your errors are. This is not somebody telling you how it goes. This is you learning how it's supposed to be done for yourself. And what resonates with you, you learn that here within 1 week. And you tell us, Eduardo, how much do you think you've learned and how much do you think you've contributed?
Well, I think it was great to be here, and I think most of my most of my doubts were solved, and I'm now more confident that I can go back home and build my own machine.
Yeah, and he's now plugged in his machine, and he's seen this work. Now, that gives you an awful lot of confidence, Cary, because you've seen your machine. You're going to take this apart and put it in your suitcase and take it home without any issues at all. And you're going to be able to make a frame, the one that you want to make, and then you just restack this up together, and then you plug it straight in the wall, and off you go. It is that simple, because we've done all the troubleshooting all this week on all of the issues, and all of the subjects.
Is Lynn still there? Could she translate for our Chinese friend, and you could tell us?
Yeah, Lynn, could you want to come in a moment? Cary wants to have a word with you.
And maybe ask him what he has learned in his time there, and what he's learned and contributed, and what he feels like he'll take home with him.
Cary was asking about Wan Chang.
Yeah, can you ask Wan Chang what has he learned while he's been here, and how has it gone for him?
他主要想问问你，你在这1个星期到底学到了什么？你的体验、收获？
收获就是，我觉得这个东西原先就是，从这个过程吧，我是在那个学习，原先有不是很懂。
Just break it down for the TV so that we can just get a sentence and a sentence translated.
Yes.
Okay, what did the...
Well, basically, Wan Chang get to learn the whole process, how to make the unit here within this week.
就是说，首先因为我呢是相信这个能量存在嘛，然后有这样一个新技术，原先我就觉得很惊奇的一种感觉，因为原先我本身是有对这种能量的个人的体验的那种
Well, Wang Chang has been practice qigong, you know, in China many years ago. So he believes there is energy, let's say prana, chi, just a different way to call it. So when he see the machine in China, see how it works, this machine can literally produce electricity. That surprised him. And this surprising and this kind of feeling to want to figure it out, brought him here.
He saw one working machine.
Yes. I agree with it.
He's actually seen a working machine in China.
And is that with the Chinese group? I know there's been a good group of Keshe students in China that have been, you know.
Yes, we know, we found one person who purchased the Maggrav unit from Italy, and he used it at home. So I contacted this guy. I said, can we come over to see and visit? And actually, we didn't plan to bring him. Then that day comes up and they said, hey, Wang Chang, come with me. You got to see this. You need to see this. So that's how, yeah, he saw the machine.
Very cool. That is awesome. So has he enjoyed his time in Peru?
他说你在秘鲁的这个好吗？感觉好吗？
好，还有就是
Yes, he enjoyed very
到了
much.
这里，Barry 做的这个用于止痛啊，或者那个东西，我也觉得非常好。我本来一直在想，因为我研究中国的那种经络嘛，然后我想把它这个东西能够回去呢，我也想做个试验，在经络的上面用这种GANS水能量，看看能不能起到我们按摩的那种效果，排除病痛。这是我的想法。
Yeah, well, this is during this week he got what he expected, but on top of that, he also saw what Dave did. You know, the health pad and this pain pan, or this kind of a pad, how it works on the pain and physical, you know, healing level. That also interested him a lot. Because I told you earlier that he practiced qigong for him, you know, own health. So he was trying to do some experiments when he go back to China, see how this works. You know, China, we talk about meridian, that same like energy flowing. So he wanted to do a lot, you know, experiment on that. So pretty exciting experience for him.
May I ask, please, if you could have him do a slight experiment for me? And that is to use the pad as a source, as a Qigong energy source.
Yes.
Hold the pad, draw the energy in, and then apply it to some task. Whatever, moving something or speaking with an animal or making a tree grow, some task.
他就刚才说，这个你把这个 pad 这个小的贴片，其实就看作我们一个能源，这个疗愈能量的一个来源，然后让这个来源去创造出来的能量去做治疗也好啊，电也好啊，是这样的。
我就是相信他这个。
Yeah, that's how he understood about this pad. It's the source of the energy, healing energy.
So you can see it's conclusive here when you come to Peru. It's not about me. It's about all of us. And I give you the very best. I'm up at 5 o'clock in the morning. I'm scrubbing the place clean here, making sure, and then I'm smoking the place out with Palo Santo, making sure that their intentions are all meet the criteria. The criteria is I'm building a machine and it's going to be switched on. And that's it. It's intention over. You put your intention into your machine, you get your machine, you go back with your machine works. Every single phase that we cover here, whether it's making the paste, we've discussed this, John, for months and months, how to do this. We've discussed how to do the baggies. We've discussed how to make your own health pen. We're selling them now, and that's it. And then we've discussed how to make all these machines here and how they work. And we have got the confidence that you come over here, you pay your $500, you have a machine going back. Not only that, you have all the aspects of energy and health that goes with it. That's a pretty good deal.
Dave, I'd like to say, so we will put, so your website is xi4.com, right? And then we'll put that under this video, and we'll put whatever contact information you need, or whatever someone would need to get a hold of you, if they would like to come over. Do they do that through XI4? Do you have a contact form there, or?
The people who are listening to this now that want to come to Peru, like instantaneously, I've got people coming in June. So I've got a couple of weeks at the end of May that are really free and you get the best attention. You're best off contacting me on MIP Peru, so that's a double P, MIP Peru on the Skype, and just have a chat with me and book your flight and show me that you're coming. Show me your ticket. That's all I need to see is your ticket and when you're coming, and I'll meet you at the airport. You can even stay the night here. It's very, very cheap, and it's very, very comfortable here. We've got nice shower facilities and stuff like that. Or you can do, as these have done, they've gone into a little bit in the jungle. Tell us about a little bit about where you're staying, Lynn. Is it nice?
Yes, well, very nice, pretty. You know, where we stay is located in the jungle, right by the river. So when we enter this little road, we instantly kind of away from the noise from the city and enter the quietness and the
Also from the heat.
Yeah, also from the heat. In town, it's really here it can be very hot in the daytime, but when we go back, at least let's say 3 degrees less, cooler. Then the town is a really nice place, and you get your own little kitchen. You can cook. Yeah, so we enjoy to stay here.
They're actually staying in a place called Wingo's, Cary. You might know it. It's down by Takawasi there. When you came here, and we went through that beautiful walk up to the Cordillera Escalera.
Yes.
So that's where they are. And then they come here. We're a good way away from there, but they come down to the bottom end of the city here. Of course, I mean, it's action stations when you come here. It's an intensive course that you go through. We work quite hard, Eduardo, don't we? So,
Dave, I want to thank you so much for this global hub, and I want to thank all of you, because through this work, we are just really practicing being a global family, and it's wonderful.
Thank you very much, Cary.
Thank you.
Thank you.
Thank you.
So let's just say, Dave, you want to look at these last few pictures I had up here of your location there? Should we do that a second?
Okay.
So this was another picture of, I guess, the Taurus field in the ice. I'm not sure who was that from you. There's the pen.
That's actually not mine, but I think that might be Heather's,
Okay.
Heather Bryant.
Let's go to your place.
Yeah. There you go.
Yeah.
Up to the 3rd floor, Nano-Coating, and there's our pens. We've got 35 more of those now. And there you see the bucket with the dye. That's what it looks like unfrozen. When it freezes, that all goes into the center as a red ball of toroidal field.
That is amazing.
Yeah, so they're all those pens. These are for sale now. The big ones are $30. There are 100 sold. So we're starting to take people's orders. Literally, if you come here and you buy these, you're helping Liliana and Lewis, the young people here, who are doing this technology at age 18 and 21. And you're literally helping them get a little bit of pay. So they'll get like 30 souls out of that.
Yeah, that's fantastic, Dave. And I know you have a number of people engaged right from your local community who are young, learning, or scientific and can offer input. So people who come to your place are really helping support people in your community.
Yeah, and if you do come here and you pay the $500 to get your machine and all your health stuff what you're doing is, in actual fact, you are creating the Keshe Foundation Peru, which we want to start forming anytime in July. We're ready to do that now, and that's what you're supporting. You can come here immediately. If you get the call to come to Peru, it's big, it's powerful, and it happens. So it doesn't, you don't tell it anything, it tells you, I'm going to Peru. And what I'm saying is, we're available for you, okay?
And it's wonderful over there. I can speak for having been there. Can you tell us what's in these jars from left to right?
That's my GANS table. Basically, you've got the 6 different types of GANs in that in the test tubes on the box at the left-hand side. And then next to that is your glorious colloidal silver, which we make gallons of here. We sell that too. And then you see aluminium GANs. Then the green pot is the GANS paste, which is the same as the paste that I've got in front of me here. And the next one's the blue, white, red, and then we've got a mixture of red and white. And then the dunking of the bobbins goes into the bucket at the end there. You literally submerge your nano-coated bobbins, and then you hang them up on the roof now because we've got the staircase, and you put them in the sun, bone dry, stick all your components together, you've got a machine. Basically, that table's got it all.
What is your dunking GANS? Is it a mixture?
It's 25% GANS mixture of red, white, and blue, and then I put a few little special dots of water in there for from the other 3 GANs that I've made from brass, silver, and aluminium. And we're going to probably make lead today. That all goes into that bucket. So it's a 25% water, 25% GANS mix, 75% water, and we dunk and leave your bobbins in there for at least 1 minute and then hang them out to dry. That's you ready for the process of connecting your machine up together, okay?
Nice.
There you go, that was a big job, that staircase. There's double header staircase with a big 8 foot by 4 foot half landing. And I'm very, very happy to use this. I go up there at 5 o'clock in the morning and I clean up, and I'm there late at night, just enjoying the views and the all the way around 360-degree panoramic view. There you go, and that's going up to the roof. And that's where we do all our nano-coating and our sun drying. There's the new office. That's where I am right now. And there's all the machines. We've got plenty more of those. Even got the one with the Wingo, which is the big dinosaur egg, John Carl calls it.
I think that's it.
Yeah. So
good. Well, thank you all so much for being here. Dave, thank your whole crew there for sharing part of their week with us. Thank you guys. Much love, many blessings.
Bye-bye. Thank you very much.
Thank you, Casey and Carl and Boss, all for being with us today. Anybody have a last couple of words of wisdom before we say goodbye?
Come to Peru. It's you.
I'm with you. I dream of being back in Peru. It's so wonderful.
I'm dreaming about you being here.
Casey, any words of wisdom for the...
Just that if it doesn't work, you've learned something. Don't be disappointed.
And let me just say, all of us knew each other before we got involved with the Keshe Foundation. So it's a really wonderful global team. We support each other. We're always there for each other. We're really accessible. I love that about the way this whole crew works together. Carl, we look forward to seeing your Merkaba with your Maggrav unit inside of it one of these days soon. I know I have all those pictures we'll have to do a show with that on it when you get moving along the next step.
Okay, no problem.
Okay,
I'd love to do a show with you on it.
perfect. Boss, thank you so much for being with us from Sweden.
Thank you. I enjoyed it.
Keep doing your experiments and keeping track of everything the way you do so carefully, and keep giving us that information, and we're all learning and growing together.
Yeah, it's great.
Yeah, cool. Thank you to our audience. Thank you to the folks from China. You saying something, Dave? You're muted. Go ahead.
Liliana's just coming. Come say bye-bye if you're coming. Here's our chief engineer, 21-year-old. The lovely Liliana.
Hola, chica.
Nice way to finish the show with Liliana.
Okay. Adios. See you soon. Much love. Okay, you guys.
Yeah.
Much to everyone out there in our audience, and we just like to say there's so much knowledge and information out on the Keshe material. You can put this into practice at home. Tune into our shows that are happening all the time. Keep learning and growing as we move into a new civilization, founded in love, peace, prosperity for all. Many blessings. Aloha. Ciao.
Ciao from Peru.
Hey, dog.